Now we're going to look at the sum of our angles when we're dealing with shapes. The most simple shape we can make is a triangle, 3 sides. The sum of every triangle, if we were to add up all their angles, is 180 degrees. And this is pretty simple to prove, and you can do it at home if you want to. Take a piece of paper and cut out any triangle you want. Doesn't matter how big, how small, or what type of triangle it is. If you tear each one of the angles off and arrange them in a puzzle, they'll arrange to be in a straight line. And a straight line is 180 degrees. We're going to take this concept of a triangle being 180 degrees and apply it to a couple problems. I'm going to be solving for variables. It doesn't really matter which one you start with. I started with x because it's first in the alphabet. So I started down here in the bottom. A triangle has 3 angles. I need to know 2 of them to solve for x. I know 63. I'm going to find this missing angle. It's on a line, so I'm going to use the concept of supplementary. The whole line's 180. If one part's 130, the other has to be 50 because they have to add up to 180 degrees. Now I know 2 of the angles, so I can find my missing angle, which is x. The whole triangle has to be 180 degrees. I'm going to subtract the 63 and the 50 to be left with x. That gives me 67 degrees. I'm going to move on to y. Y is actually a vertical angle. I was given that this was 63, so that means y is also 63. And last, I'm going to go to z. It's going to work just like x at the bottom. I know the entire triangle is 180 degrees. I know 2 of my angles. So 180 minus 85 minus 63 is going to leave me with what z is, or 32. Let's try another one. This time I only have the one variable, and it's in every one of my angles. So I'm going to take all these angles, and I know that they have to add up to 180 degrees. So I have 180 plus x, plus 6x plus 10, plus x plus 2. Combining like terms, 1x, 6x, and 8x and 1x is 8x. 10 and 2 is 12. Solving by subtracting 12 from both sides, and then dividing by 8 gives me 21 degrees. Now let's take this concept of the triangles being 180 degrees and see what happens for shapes with more sides. So we'll start with a quadrilateral, 4 sides. I can take any quadrilateral and it will split into 2 triangles. Both those triangles are 180 degrees, which means a quadrilateral has a sum of 360. A pentagon has 5 sides and will make 3 triangles, each being 180 degrees for a total of 540. A hexagon has 6 sides. It'll split to make 4 triangles, again each with 180 degrees for a total of 720 degrees. I can take this pattern of these 180 degrees and make a formula. It says you're going to have 180 degrees because we're dealing with triangles. And the number of triangles is always the number of sides minus 2. In a hexagon, we have 6 sides and 4 triangles, 6 minus 2. A pentagon had 5 sides minus 2 for 3 triangles. And this is true for any polygon. If you don't like having the words written out, you can replace number of sides with n. Now we're going to take this formula and try a couple problems. First, a regular polygon. Remember, a regular polygon means all the sides and all the angles are the same. They're all congruent. The measure of each interior angle is 160 degrees. And I want to know how many sides it has. So I'm going to do a little manipulation of our formula. It's 180 times the number of sides minus 2. I need to know what n is. Over here on the left is my sum of the interior angles. I know that each angle is 160 degrees and there are n of them. So 160 times n. From here on out, it's algebra. So I'm going to distribute my 180. 180 times n is 180n. 180 times negative 2 is negative 360. I'm going to move 180 over to the other side since those both have in. I don't want to move 160 in because it's all alone. Don't worry about the negative number. It'll take care of itself. Negative 20 in is equal to negative 360. I'm going to divide both sides by negative 360 to get n equals 18. The biggest problem I see students make with this particular style problem is over here at the very beginning. They want to put just 160 instead of 160 in. Remember, every angle is 160, not the total. The total is 160 times every angle, and there are n of those angles. Let's try a slightly different problem. We're going to find the sum of the interior angles of a 20gon. This one's different because I told you the number of sides, and it honestly makes it easier. My formula says 180 times the number of sides minus 2. I told you there are 20 sides. So that's the 180 times 18, which is just 3,240, and that's the end of the problem. So simpler than the one that we just did before it. Let's do one more. I've given you a shape, and it's got some missing variables. This has 6 sides, 1, 2, 3, 4, 5, 6. So I'm going to do the number of sides minus 2, and I'm going to multiply that by 180. That should be equal to all of these numbers added together. Simplifying that, on the right-hand side, 6 minus 2 is 4. 4 times 180 is 720. Over here on the left-hand side, 3x plus 6x is 9x. And adding all my numbers together, 150 plus 120 plus 150 plus 120 is 540. I'm going to solve that. Subtract 540 from both sides to give 9x equals 180. Divide by 9. 180 divided by 9 gives me x equals 20 degrees.